Hi there. Today we are going to study about Coulomb's law in vector form. Before that, we need to study about the scalar form of Coulomb's law. And in vacuum, you must be knowing that force of interaction between the two charges is given like this: 1 upon 4 pi epsilon naught q1 q2 upon r square, where q1 and q2 are the magnitude of the two charges and r is the distance between the two charges. And here this vector, the 1 upon 4 pi epsilon naught vector, that is the constant, and it depends upon the material medium where it has been kept. Here it is the case for vacuum, so we have taken 1 upon 4 pi epsilon naught, where epsilon naught is the permittivity of the free space. Okay, then if we are studying about the Coulomb's law in vector form, then what is the need of that is the thing that we know very well, that the force is a vector quantity, and also the r, that is the position vector. If we are considering the position of the two charges in a two dimensions, then we must be taking the direction of it. So in vector form, how we are going to do it, as shown here, we are going to take three cases here. First case, when two charges are like charges and positive charges. Okay, so like charges का मतलब, the meaning of the like charges is the charge is having same sign. Here we are taking the two charges as positive charges, and we know very well that the distance between them is taken as equal to r, and the product of the two charges will be greater than 0. It is obvious. Okay, then if we have to take the position vector, then either we will be taking r12 or r21. Here the gap given on r12 signifies that this is a unit vector, and it is trying to tell you that the position vector is the r is a position vector. Okay, and here two forces are taken. Why two? Earlier it was taken as one only. Here two forces are taken for the reason that the force experienced by q1 due to q2 will be written as F12, force experienced by 1 due to 2, and force experienced by 2 due to 1 will be taken as F21. And because the two charges are like charges, so there will be repulsion, force of repulsion between them. So F21 will be having the direction equal to this one, and F12 will be having the direction equal to this one. Okay, and likely we are going to take the second case. Here we are taking the two charges as negative charges, and again the product of the two charges will be greater than 0, and if the distance is taken as r, then as done earlier, F12 will be directed like this and F21 will be directed like this. And you must be knowing that F12 means force on 1 due to 2, and F21 means force on 2 due to 1. Force on 2 due to 1 will be in this direction, and force on 1 due to 2 will be in this direction. Okay, now the third case we are going to take. Before that, we must be writing the Coulomb's law in vector form for these two cases, and it will be written as this only. Here you can see that the position vector has been written like this, unit vector has been put, and you see that the direction of the r21 and r12 are similar, so they are taken like this. Here F12 and r21, okay, and F21 will be having similar direction as r12, hence it is written like this. Okay, now we are considering the third case, where q1 q2 is less than 0, that is the two charges are unlike charges. Then what will happen? The two charges will be attracting each other, and here force on 1 due to 2 was earlier directed towards this direction. Now it will be directed towards this direction, and F21 will be directed towards this direction. And for this case also, in vacuum, we will be finding that F12 is equal to 1 upon 4 pi epsilon naught q1 q2 over r square. R12, yeah, F12 is directed towards this, and R12 is directed towards this, 1 from 1 to 2, and F21 will be equal to 1 upon 4 pi epsilon naught q1 q2 upon r square r2 1. Okay, then so we will be if we are checking out the directions, then we will be finding that in all the three cases F12 is equal to minus F21. That means force on 1 due to 2 is equal to force on 2 due to 1, but oppositely directed. Okay. Here, this is the modified form of the vector form of the Coulomb's law. Here you will be finding that we have taken r cube in the denominator but multiplied by r2, and this r12 and r21, these are the cases for unlike charges, and these r12 and this r21 is putting the right hand side into vector, and here it is a vector quantity, it is also now a vector quantity. So this is the vector form, and actually the Coulomb's law is the inverse square law, but here r cube is taken for the reason that we have to take r12 over here in the numerator part. Okay, now if we are cutting this, then we will be finding r square. Now what is the importance of vector form of Coulomb's law? It is obvious that it is going to tell you about the direction of the force applied by two charges, and also it helps to prove the Newton's third law of motion, and it tells that the force applied by the two charges having same magnitude acts as action reaction here. Okay, this is the vector form of Coulomb's law. Thank you.